All right, in this section, we're going to be looking at ratios, proportions, and proportional reasoning. And there are two things we'll look at. We'll focus on proportions and scale drawings. Okay, we'll first define what a ratio is. A ratio is used to compare quantities. It's also usually written in the form A over B. And it's also written as this, A with the two dots in between, and then B. So it can be written this way, or it can be written as a fraction, A over B. It's also used to represent part-to-part, part-to-whole, or whole-to-part comparisons. And here's some examples of just that. There were 7 males and 12 females in the Dewdrop Inn on Monday evening. In the game room next door were 14 males and 24 females. Okay, now in part A, you're going to express the number of males to females at the inn as a ratio, which is, of course, part to part. So, males to females at the inn, there were 7 males and 12 females at the Dewdrop Inn. So, we write that as a fraction 7 over 12, because that's the number of males to the number of females at the end. And then part B, express the number of males to females at the game room as a ratio. Again, this is part to part, male to female. There were 12 males, 24 females in the game room. So as a ratio, it would be 14 to 24. So 14 over 24, we can reduce to 7 over 12. Okay. Now this is the same example, but here we're going to look at part to whole. So here we're going to express the number of males in the game room to the number of people in the game room as a ratio. So it's part to whole. 14 males. Now, the 38 comes from the sum of the number of males and the number of females. 14 plus 24 would give you 38. So the number of males to the number of people in the game room will be 14 over 38, or if you reduce that, it will be 7 over 19. Okay, next we'll look at proportions. A proportion is a statement that gives that two given ratios are equal. A proportion is a statement that two given ratios are equal. And in this case, if A, B, C, and D are all real numbers and B is not equal to 0, D is not equal to 0, then the proportion A over B is equal to C over D. That would be true if and only if we take the cross product of A and D, and that's equal to the cross product of B and C. Okay. So here you would have a proportion if their cross products are equal to each other. Okay, let's look at this situation. Ali and Bent typed at the same speed. Ali started typing first. When Ali had typed 8 pages, Bent had typed 4 pages. When Bent has typed 10 pages, how many has Ali typed? Now this example is what we call an additive relationship. Okay, so here students should see the fact that since 2 people typed at the same speed, when Bent has typed an additional 6 pages, Ali should have also typed an additional 6 pages. So she should have typed 8 plus 6, or 14 pages. Okay. Now here's a proportion that's an example of a multiplicative relationship. Carl can type 8 pages for every 4 pages that Dan can type. If Dan can type 12 pages, how many pages does Carl type? Okay, so in this case, this represents an example of a multiplicative relationship. And to figure this out is this. Since Carl has typed twice as fast as Dan, he will type twice as many pages as Dan. Therefore, when Dan has typed 12 pages, Carl has typed 24 pages. As you can see here, Carl typed twice as many pages as Dan did. Okay, here's another example of a proportion, how to set up a proportion anyway. If there are 3 cars for every 8 students at a high school, how many cars are there for 1,200 students? Okay, so here, if we look at the ratios for cars to students, 3 cars for every 8 students, so that ratio will be 3 to 8. That same ratio must be set up for the other side of the equation. Because if this is going to be cars to students, the other one must be cars to students. So we're trying to find out how many cars, which is going to be X, for 1,200 students. The 1,200 will be on the bottom, because the ratio on the right side of the equation has to be the same as the ratio on the left-hand side. So you have 3/8 equals to X over 1,200. Now, if we do cross multiplication, you'll have 8 times X, that's 8X. That's equal to 3 times 1,200. And 3 times 1,200 is 3,600, which is going to be equal to 8x. Now you'll have to divide both sides of this equation by 8 to get 450. So x will be 450, meaning that there are 450 cars for 1,200 students. Okay, next is the constant of proportionality. If the variables x and y are related by the equality y is equal to k times x, or we can say k is equal to y over x, then y is proportional to x, and k is the constant of proportionality between y and x. Okay. Now sometimes they use y is equal to k over x in a indirect variation, but that k is called your constant of proportionality. Okay, a central idea in proportional reasoning is that a relationship between 2 quantities is such that the ratio of one quantity to the other remains unchanged as the numerical values of both quantities change. Okay, now let's look at the cross multiplication method. Okay. In this case, the instructions in solving proportions should include methods that have a strong intuitive basis. The so-called cross-multiplication method can be developed meaningfully if it arises naturally in students' work, but it can also have unfortunate side effects when students do not adequately understand when the method is appropriate to use. Okay. And other approaches to solving proportions are often more intuitive and also quite powerful. For example, when trying to decide which is the better buy, 12 tickets for $15 or 20 tickets for $23, students might choose to use the scaling strategy, which is finding the cost for a common number of tickets, or a unit strategy, which is finding the cost for a single ticket. Now let's look at the scaling strategy in this case. Now we have 12 tickets for $15 and 20 tickets for $23, and we want to find out which one is the better buy. So here the scaling strategy for solving the problem would involve finding the cost for a common number of tickets, or the least common multiple. And in this case here for 12 and 20, the least common multiple, or the lowest number that is divisible by 12 and 20, would be 60. So in the first plan, since 12 tickets cost $15, 60 tickets would cost $75. In other words, to get that, they multiply the 5 times 12 to get the 60, and also multiply 5 times $15, which is $75. And in the second plan, since 20 tickets cost $23, multiply 3 times 20, you're going to get 60 tickets. 3 times $23 will give you $69. So if you compare both of these plans, the second plan will be the better buy. So 20 tickets at a cost of $23 would be the better buy. We can also use the unit rate strategy for solving this problem, involving finding the cost of a single ticket under each plan, and then you compare the unit cost. Okay, so here we're going to take the same example of 12 tickets for $15 and 20 tickets for $23, and we're going to use the unit rate strategy to find out which one would be the better buy. So in the first plan, 12 tickets cost $15. A single ticket would cost $1.25. In other words, you take $15, divide that by 12, you'll get the cost of one single ticket. Then in the second plan, 20 tickets for 20 will cost $23. So take $23, divide that by the 20 tickets, you'll get $1.15. So as you can see here, the second plan would be the better buy because it's cheaper to buy a single ticket at $1.15 than it would be to buy a single ticket at $1.25. Here's another example that is related to ratio and unit rate. Kai, Paulus, and Judy made $2,520 for painting the house. Kai worked 30 hours, Paulus worked 50 hours, and Judy worked 60 hours. They divided the money in proportion to the number of hours worked. If they all earned the same rate of pay, how much did each earn? Now, to solve this problem, we're going to let X be the unit rate or the rate of pay per hour. Now, Kai worked 30 hours, so that means 30X will denote the amount of money that Kai received. And Paulus received 50X because he worked 50 hours, so that would represent 50X. Okay, and then similarly, Judy received 60X. She worked 60 hours, so her pay is 60 times X. And the total amount of money received is going to be this. You're going to add 30X plus 50X plus 60X. That's $2,520. Combine all your like terms, you're going to get 140X is equal to 2,520. Then you're going to divide by 140 on both sides of the equation to get X is equal to 18. So the unit rate of pay would be $18. So now we want to find out how much did each receive. So Kai received 30 times X for working 30 hours, so 30 times 18 would be $540. So Kai received $540. Paulus received 50 times 18 because he worked 50 times X, 50 hours, so 50 times X or 50 times 18 would be $900. And then we multiply the $18 per hour times 60 hours that Judy worked, so she will receive $1,080. Okay, so these are the amounts that each one of them will receive. Now, if you add these numbers up together, you should get $2,520. Okay, we'll talk about proportion. Well, some more things about proportion. For any rational numbers a over b and c over d, with a not equal to 0 and c not equaling to 0, a over b is equal to c over d if and only if b over a is equal to d over c. Okay? This will be true if and only if the reciprocal of a over b and c over d is true. And for any rational numbers a over b and c over d, where b, c, and d are not equaling to 0, a over b will equal c over d if a over c is equal to b over d. In other words, the ratio of the numerators is equal to the ratio of the denominators. Okay, that's basically what that statement is saying. Okay. All right, next we're going to see how this is applied to scale drawings. Ratio and proportions are used in scale drawings. The scale is the ratio of the size of the drawing to the size of the object. So in this case here, the floor plan of the main floor of a house in the figure is drawn in the scale of 1 to 300. Find the dimensions in meters of the living room. So here's the living room here, and this is 2.5 centimeters, and this distance is 3.7 centimeters. And we want to find the dimensions of that living room based on this scale of 1 to 300. Okay, because the scale of 1 to 300, that means that 1 centimeter in the drawing represents 300 centimeters in, or 3 meters in true size. The 3 meters comes from 300 centimeters divided by 100 centimeters in a meter, which will give you 3 meters. So if we have 3.7 centimeters, that's going to represent 3 times 3.7 times 3, or 11.1 meters. 2.5 centimeters represents 2.5 times 3, or 7.5 meters. Okay? So the dimensions in that living room are 11.1 meters by 7.5 meters. Okay? So that's how we can use, when we're given a scale drawing, it'll give you what the scale is, and then you can use that to find out what the actual length, actual dimensions are in real life. Okay, so this will conclude this particular section on ratios, well, proportions and proportional reasoning.